Hi friends, welcome back. Today we are going to solve LeetCode problem 226, invert binary tree. So the problem says that given the root of binary tree, invert the tree and return its root. So so inverting tree means, let's take this example over here. So inverting tree means all the left node will go on the right side and right node will come on the left side, right? So for example, if you see here, this 2 is the left node, so it will go to the right side, right? As you can see here, it go to the right side, and 7 is the right side node and it went on to the left side, right? So it is applicable for the subtrees as well. So same thing will happen for 1 3 also. 1 will go here at the 3 place and 3 will come at the 1 place, right? Here you can see 3 came on the left side and 1 went 1 on on the right side. So same thing with 6 and 9 as well. So 6 went on to right side and 9 went on to left side, right? So this is called as inverted binary tree. So so let's first let me show you the implementation first, and we will come back and again I will explain you how the recursive solution works with an example. So first thing, in the recursive solution here, we are just going to check the base condition. Where root is equal to null, then we will just return null, right? That is the base condition for our recursive function. And then if there is a root, there is a value basically like left node and right node. So what we will do is we will call the invert tree and we will pass the left node here and we will pass right node here, right? For inverse, to invert the tree, and we will get a left node back here and we will get a right node back here, right? Once we get this back, what we will do for the root node is we will change the left to right now, right? So we will say left root dot left is equal to right basically, and root dot right is equal to left, right? So we have exchanged the left and right subtrees basically, and at the end we are just returning root. So this is as simple as implementation. So what this implementation will do, let's just take a example here and I can explain you how the recursion will work in this case. So when we are calling the recursion on the root, right, the recursion directly doesn't work on the root, it goes on the as deep as possible first. So it will go, let's say, on the right side, then it reaches 2, then it reaches 1, right? First, so 1, it will get null node on the left side and null node on the right side. So it will, even if that is exchanged, it is still same, right? Because both are null, right? So after that the one node will get back to the 2 actually, which is calling function, right? It will get back to the 2, and where we will get that back in this statement, right? This is what happens actually. So it will give us back a left node actually, right? So similarly, when it is the recursion goes to the 3, it will call again left and right, which is both null. So it will after that it will return that node 3 here to the node 2, right? So this is what that statement does. The invert tree of root dot right, it is going to give us the right node back, right? So basically, when the the recursion or recursive function is called from this node 2, this is what we got, right? We got 1 from here, we got 3 from here. So what we do after that, we will just exchange that left and right? So what we will do, I'll just show you here. So what we do actually is we exchange now. So we put 3 on the left side and we put 1 on the right side. That's what we are doing, and the same thing we have done it here in the code. And after that we return this node. So this node where we return to the 4 basically, right? This is where we return this node. So this is one tree that we form. So similarly, when we apply the recursion on this subtree, right, this subtree, so what we get, let me just write down here. So 7 we will get here, right? 6 will go on the right side now, and 9 will come on the left side, right? So that's what we do. And then this recursion will be done, and the 7, this root, this node will be returned to 4 basically, right? this node will be returned to 4, which is the calling function from 4, and here the 2 will be returned to 4, right? That's what happens. So 2 is the left side now, this 2 is left side and 7 is right side. So what happens is they will be exchanged now, right? This one will go on the left side. So as you can see here, right, this one went on to the left side, right? 7, 9 and 6. So that's what happens, 7, 9, 6, and 2, 3, 1 will go on the right side. 2, 3, 1 go on the right side for the 4, right? That's how the recursive function works. So so it goes all the way down and then it will bubble up like this basically, and it will reach to 4, and then again the subtrees will be swapped, right? This tree will be swapped, the right will go to left and left will go to right side. So that is how the recursion works. So the implementation is very straightforward. We just first check the base condition. If the root is null, we will just return null. Otherwise, we will call the roots dot left and here root dot right, and we get the left side subtree, we get right side subtree, and we will just exchange left and right side, right? Root dot left is will go to right, and root dot right left will come here, right? So left will go to right side and right will go to left side, and at the end we just return root. So that's pretty much it. So let's just take one example here. So this one is the same example, right? You can visualize the tree here. So this is the tree, right? So I'll show you. So as you can see, 4 2 7 1 3 and 6 9. So same example we are trying now. So let's just run this code on that example. So as you can see, now we are getting the correct result here on this example. If you want, we can try some more examples here on the as a test case. So it's better to use all the examples, right? An empty tree. So all the examples are passed here. So we'll just submit our solution. So our solution is 100% faster, 0 ms, and 52% on the memory side, which is pretty good. So make sure that you practice this invert binary tree problem, because in some of the big tech companies in the initial rounds these problems will come, in the binary tree. So make sure you can solve this problem and understand this problem. If you have not checked my playlist on the LeetCode solutions, please check it. It has over 80 solved problems explained in details with Java code, as well as it has a dedicated playlist for Java interview, where the frequently asked questions and answers and how to answer those questions. Some tricky questions that are asked in the interviews in past are there. Check it out. Also, please make sure you like if you find this video helpful, please leave a like and subscribe to this channel so it can reach to more people. Thanks for watching the video.